divided by the mass of the ice, that is nothing but the 70 gram. So I can put here the value of the 70 gram. So if you calculate this value 23,500 divided by 70, it is coming out to be about 336 joule by gram. Joule by gram. So why it is joule by gram? We can use this is Q by M. Joule is for Q. Q is nothing but heat. Heat is the energy. Joule is the unit for energy. And G for gram mass. This is M. M is nothing but the mass, and it is nothing but measured in gram. Here we can see it is nothing but 70 gram. That's why we have used gram. So whatever given in our inputs or in the question, that those things we can use over here. So this is Q by M, so that's why the unit is joule by gram. Again, you have to put the values over here, that is nothing but 336 joule divided by gram. Okay, so we have calculated the value without changing anything to our input values. That's why our units remain the same. Now the second sub question you can read over here. The thermal energy that causes the ice to melt is transferred from the laminate as it cools. The loss of this thermal energy causes the temperature of the 300 gram of the laminate to fall by 19 degrees Celsius. Okay. Calculate the specific heat capacity of the laminate. Okay. So we had seen the ice melts and it becomes the water at 0 degrees Celsius. That means ice is acquiring or absorbing this energy 23,500 from what it is absorbing. It is absorbing from this laminate. Okay, that means what is happening with the laminate, it is losing the heat. Okay, laminate is losing the heat, it is giving heat to the ice, so ice is melted. So when the laminate is losing the heat, its temperature decreases. Its temperature basically decreases by how much amount? 19 degrees Celsius. Okay, so that is nothing but the change in temperature. That is nothing but the change in temperature. So initially it would have the temperature by the value 19 degrees Celsius higher than the current value. Okay, current value of the temperature of the lemonade is nothing but the 0 degrees Celsius, because the final temperature of the drink is 0 degrees Celsius. That means lemonade would have the temperature of 19 degrees Celsius. After it gave its all energy to ice, that means after it gave 23,500 joule of energy to the ice, its temperature falls and now its temperature becomes the 0 degrees Celsius. So initial temperature of the lemonade must be 19 degrees Celsius, and after giving the energy it has become the 0 degrees Celsius. So change in temperature, this is nothing but what? This is a fall, that means change in temperature, that is nothing but 19 degrees Celsius. And we want to calculate the specific heat capacity of the laminate. So for that for laminate there is only the temperature change, there is no state change. It was initially the liquid and now also it is a liquid. So there is no state change occurring with the laminate. So we can use the formula of the specific heat capacity. Q is nothing but M into C into delta T, where M is the mass, C is the specific heat capacity, and delta T is the change in the temperature. So I will write down this formula over here. So we can write down over here. Now if you put these values, value of the Q is nothing but 23,500 divided by mass is nothing but 300 multiplied by the change in temperature, that is nothing but this 19 degrees Celsius. So the overall value, if you calculate, then it is coming out to be about 4.1 joule by gram into degrees Celsius. So I can put the unit value over here. So it is nothing but 4.1 joule by gram into degrees Celsius, because it is coming from the formula only. It is Q divided by mass into delta T. Q is nothing but joule. Our energy was in terms of the joule. Mass is nothing but 300 gram. This mass, so I put here gram into delta T. The temperature of delta T is nothing but the degree Celsius. So same value I have put over here. We can estimate the unit from the formula itself. So here I will write the formula value again, the 4.1 joule by gram into degree Celsius. Okay, so this will be our final answer. Now I will move towards the third sub question. The melting ice floats on top of the lemonade, and explain the process by which the lemonade at the bottom of the drink becomes cold. Okay, so this is our common observation. If you put the ice cubes in the cold drink, that generally floats. And why does this happen? We know that it is because of the density difference. The denser object always goes down and the lighter objects goes up. So it's all about the density. So we can write down over here the cold water is denser than ice, and that's why the ice, we can write down, that's why ice floats ice floats on the top of the lemonade. Okay, and about the process by which the lemonade at the bottom of the drink becomes cold, that for that we can write down due to the convection current, and write down cold water, or we can write down this way, the warmer water first. First of all, warmer water rises, and cold water deposits at the bottom. So we know that we have learned three kinds of transfer of the heat: conduction, convection, and the radiation. So in the convection, what happens? The water particles themselves move from one point to another point, and the warmer particles always goes higher or rises, and the cold particles generally goes down. So in this case also, in the case of the lemonade also, the warmer water rises and the cold water, relatively cold water, deposits at the bottom, and that's all because of the convection current. So this is the process by which the lemonade at the bottom of the drink becomes cold. Now we will move towards our last problem. So here is question number 4. A liquid in glass thermometer has a linear scale and the range of 120 degrees Celsius. So what is mean by the linear scale? What is the mean by this linear? So I already told you the linearity, meaning if there is the same expansion of the liquid in this liquid glass thermometer for same temperature range. Suppose some temperature is going from 0 to 5 degrees Celsius, and liquid is expanding, suppose 5 centimeter. And suppose for next range, if the temperature is going from 5 degrees Celsius to 10 degrees Celsius, this temperature difference is also 5 degrees Celsius, and if suppose we have the same expansion of the liquid, that is again 5 centimeter, then we will call it as a linear scale. So for same temperature difference, there should be same expansion of the liquid or distance moved by that liquid in the liquid in glass thermometer. Then only we will call it as the linear scale. It is like the linear equation. Okay, so we can write down over here the linearity, meaning is that when there is the same distance moved by liquid for the same temperature difference. Okay, so that property is nothing